Good day students, today we will be discussing about satellite image processing techniques. Of course, before going to the various aspects of image processing techniques, let us see some of the important aspects of satellite, how your satellites are used to acquire information. So, in general we say remote sensing. Remote sensing, as all of you know, is nothing but the knack or art of acquiring information about an object without being in physical contact with the object. So, let us understand that without being in physical contact of the object. Of course, do not get confused with remote sensing and remote control. So, remote control, in fact, we all will have a kind of a control, we will be using it very frequently at our homes, but where in which we will have a equipment with which you can control the aspect, whereas in case of remote sensing it is not like that. We try to understand or acquire information about an object without being in physical contact with the object. So, this is what the topic is, satellite image processing techniques. As I was just telling you, remote sensing techniques are nothing but acquiring information about an object or about an area from above the surface, that is from say space. So, that is the most important thing. Of course, it can also be from air. So, invariably satellite remote sensing and aerial remote sensing, there are two ways in which you can acquire that sort of an information about an object. What do they need or what exactly we will be working with, in the sense we will be trying to understand the various aspects or characteristics what is present on the earth surface, right, from land resources, water resources, whatever is that is without being in contact with that from a distance. What is the requirement for remote sensing? The very important context is that it depends on the electromagnetic radiation or the electromagnetic energy which is available free of cost. That is the most important thing, it will be available as a free of cost energy which is emitted from or emitted by the objects, and that energy which is reflected by the objects are captured using a methodology. So, let us not go into that detail right now. Let us talk about what is that electromagnetic radiation, how is it available, where is it available, where from it is available, and let us see how various objects react with respect to the electromagnetic radiation and how we will be capturing the reflected or the emitted energy by the objects. So, that is what is important. So, what exactly we will be doing is we will be looking at the physical nature of the objects which are spatially distributed. So, that is in other words, spatially distributed objects are seen from various altitudes. Of course, previously remote sensing was done from a very high altitude. Relatively now, because of the advent of improvement in technology, we find that remote sensing is being done at lower levels, say even from 150 kilometers from above the surface. Let us see the other aspects. As I was just telling you right now, platforms which are normally used to acquire remote sensing data, that is those platforms which are used for acquiring information from space or from air. First and the foremost, right from a long time it is the aircraft. Aircrafts could be low, medium and high altitude. As I was just telling you, 1 kilometer, 2 kilometers, 5 kilometers, 10 kilometers, depending upon the application, depending upon the study. Normally satellites are, these aircrafts are flown at a height of 1 kilometer, 2 kilometers or 10 kilometers from above the surface, and it is photographed. Of course, nowadays images are also taken using your aircrafts. Initially for a long time photographs were taken, and we will see that aspect at a later stage. Next important is that what level of information you require. So, that is what we say, higher level of spatial detail. So, the better or the greater spatial detail if you require, you go for aircrafts. Of course, the only difference between aircrafts and spacecrafts is that you find that these are inordinately expensive in nature, but still after all depending upon the purpose and the application, we use either aircrafts or satellites for our remote sensing purposes. Next we could talk about the satellites. Satellites, again we say about two important satellites, one is your polar orbiting satellite and the other one is your geostationary satellites. As the name indicates, polar orbiting satellites, those satellites which will be going around from one pole to another pole, invariably from the north pole to south pole, and it will be going around the earth surface, and that is one type of satellites. The other type of satellite is your geosynchronous satellites. As the name indicates, it synchronizes the speed of the earth and it will always looking at a specific location. Whereas in the first case, namely your satellites which sun synchronous in nature, normally goes around the earth surface, wherein which it will be seeing various parts of the earth at a given time. Whereas in the case of geosynchronous satellite, exclusively all the time throughout its lifetime rather, it will be looking only at one part of the Earth's surface. That is why it is called geosynchronous satellites. So, please bear that in mind. These are the two things which are very important as far as the satellites are concerned. Now, the first type, satellites which are going around the Earth's surface, namely we call it as polar orbiting satellites. So, as we just look at the geostationary satellites, we are talking about the geostationary satellites. Satellites are two types. Basically, they are polar orbiting satellites. Those satellites which are normally orbiting at an altitude of 800 to 900 kilometers from the Earth's surface, initial stages. Of late, satellites are also orbiting at an altitude of 150 to 200 kilometers, depending upon the type of satellite. There are numerous varieties of satellites which are going around the Earth's surface. As the name indicates, polar orbiting, that means it will be going around from one pole to another pole, say from North Pole to South Pole and so on and so forth. Whereas, other type of satellite which are also equally important for various applications, namely it is called as geostationary satellites. As the name indicates, it will be looking at a particular part of the Earth, stationed towards a particular part of the Earth, geostationary, and you just see the height at which it will be orbiting at an altitude of say 35,900 kilometers or roughly 36,000 kilometers is the height at which these satellites will be orbiting. And as I was just telling you, as it is always looking at a specific place, throughout its lifetime 24 hours orbit will be there, and it will be just looking at only one particular place of the Earth's surface. Invariably, let us see the different types as it is. The first, as I was just telling you, is your polar orbiting satellites, or the other one is your geostationary satellites. Let us talk about the geostationary satellites. As I was just telling you, stationed towards a particular part of the Earth, and these are very characteristic as they look at one part of the Earth, and they are the most important satellites which are used for say telecommunication purposes and weather forecasting purposes. So, that is what is the most important thing. Initially, they thought that it will not be possible for India to go for weather forecasting or telecommunication using geostationary, because it is a very expensive process. But after a lot of deliberations way back in 1980s, they started working on this, and they were successfully able to launch satellites and through with the help of foreign countries. Of course, of late we are using our own technique or methods to launch our own satellites. You know, you must have heard about Sriharikota launching station, where we will be launching the satellites on our own. So, these geostationary satellites I was telling you are looking at 1/3 of the Earth's surface, invariably 1/3 of the Earth's surface or throughout its lifetime. Hence, if we just consider 1/3, then we can say that for to cover the entire Earth at a given instance during any part of the time, we require a minimum of 3, isn't it? We require 3 satellites to cover the entire Earth's surface. In fact, we talk about something like a live cricket match which is going which is next door, next to you. It does not mean that just because you are next door to the cricket stadium or a football stadium, that does not mean that you will be receiving the data directly. So, entire thing will be coming only through the satellites. Even if you are close to the place of the event, these data are normally sent through the, you must have seen huge dish antennas placed outside these event places, where in which it is passed through the dishes to the satellite receiving stations which are normally placed in the your New Delhi, where in which again it is re-relayed to the viewers. So, that is the way we normally get the data. And obviously, as I was just telling you, whenever you are looking at watching your news, invariably you will find at the end of the news normally they just show you the weather forecast, and you must have seen during that particular time while they are showing that map of India, they would have just drawn on a global scale. You will find the entire globe or a part of the globe which will be displayed there, and they would have drawn India map or just outline of India indicating which part we are looking at. Then we will know where you are looking at, and they will be describing how the weather is that on that particular day, isn't it? So, this is what is our general experience for the general public. Otherwise, as a remote sensing scientist, we should know what is the importance of that. So, it is not only that we try to use these satellites for weather forecast, we also use it for say disaster management. So, one of the major applications of this remote sensing, this particular type of satellites is your disaster management, weather forecast and telecommunication. That is all about your say geostationary satellites. Of course, maybe other small applications may be other, major applications are these 3. I was just telling you about the satellites. which are polar orbiting in nature. As the name indicates, polar orbiting satellites. Those satellites which will be normally orbiting at an altitude of 800 to 900 kilometers, much above your atmospheric attraction. So, whatever is there, that particular those satellites are normally orbiting from one pole to another pole. Say, we just observe very carefully how just it goes. So, when you just look at the satellites, it just goes like this around the Earth's surface. So, when it is going like this, you find the characteristic feature of the Earth comes into play here. What are the characteristic feature of the Earth? As all of us know very well, that Earth has got a very characteristic feature, namely it revolves on its own axis and also goes around the sun, isn't it? So, revolves around the sun also rotates on its own axis. So, when it is rotating on its own axis, you will not be seeing the Earth's surface at any point repeated rather. So, at the same time, it is not only rotating on its own axis, or it also goes around the sun. So, when it is going around the sun and also rotating an axis, that particular analogy has been used to the advantage of remote sensing application. So, wherein which what they try to do is, or what they tend to do is that, so we see the satellites are launched in such a way, it just goes around the entire Earth surface throughout its lifetime. At a given time, it will be looking only a part of it. So, when you just look at the image very carefully, you will find that satellites are going around the Earth, and how it is going, a kind of a strip of land, a part of the land is looked by the satellite. So, that part of the land may be, depending upon the type of satellite and also the various other details, you will find it will be some 10 kilometers, 20 kilometers, 100 kilometers, 170 kilometers, and that width is called as the swath width. So, yeah, as you can see in the image, this is the swath width. So, this is the total area covered by the satellite at any given time. So, by the time the satellite goes around like this, so what will happen, what would have happened to Earth's surface? Earth's surface would have rotated on its own axis, also gone around the Earth's surface. So, that is the best part of it. You can see on the left and the right. So, you see a part of the globe and the satellite going around, and by the time it makes one complete round, the Earth also would have rotated and also revolved around the sun. So, this technique, the analogy has been used very effectively in remote sensing, and we find that this particular satellite will be covering the Earth's surface in a period of time. It is not that it can cover entire Earth at a given time. Normally, it will take about say 16 days to 21 days, depending upon the type of satellite and also the width of the swath which it is covering. So, when you talk about that particular aspect, we say that by the time the satellite completes one complete round around the Earth's surface, the Earth also would have rotated and also revolved around the sun. That means, when I am seeing now Anna University or whichever place we we find that after a particular time, this particular satellite would not be seeing after one rotation, it will not be seeing the same place. It will be seeing some other part of the city or some other part of the say our state or India, whatever is that. So, period of time it takes 15 to 16 or sometimes even 21 days, depending upon, as I told you, the swath width. The time taken will be 21 days to complete one rotation, one complete coverage of the Earth's surface. That means, if I am seeing today this particular place or a spot, or after 15 days only I will be in a position to see the same spot again. Now, so what the satellites are designed in such a way? Normally, it is rotating at the speed as you know, the Earth, I was telling you, it depends on the rotation of the Earth and as far as you are say the revolving. So, it synchronizes with the speed of the Earth. The satellite also will be synchronized with the speed of the Earth with respect to the sun. Hence, we call it the sun synchronous satellites. So, these satellites will be covering part of the Earth at a given time, and over a period of time only it will be covering the entire Earth. So, as I was just telling, maybe 16 days, 21 days. Of course, nowadays you also have satellites covering at 12 days because the largest swath width. Of course, there are satellites which will take a longer time, provided it covers a less area. So, actually what you should remember is, the greater the area it is covering, the lesser the number of days, the lesser the area it is covering, the greater will be the number of days to cover the entire Earth. So, that is what is the most important thing as far as your polar orbiting satellites are concerned. So, let us see our other details. You can see that different satellites, how they are orbiting around the Earth's surface. So, normally I was just telling you about that. So, the geosynchronous satellites, 36,000 kilometers above the surface. And as I was just telling you, what are the advantages or the purpose of this satellites is your commercial as well as military communications, mainly it's for telecommunications. So, these are normally used for not only for general commercial purposes or civilian purposes, also for military purposes, especially ballistic missile launch. You just imagine how important these satellites will be or what role it will be playing in military applications. We also have what is called as medium earth orbit, or MEO we call it as. So, which will be used for say your navigation purposes. So, all of you must be using it. Of course, in our days it was not there, talking about GPS, and even in the case of say in an ordinary smartphone you have GPS facility. So, these GPS, as you know, that global positioning system, and for any other method of locating oneself, maybe it could be Galileo or the GLONASS, different types of methods of locating oneself, and that it all depends on the country. One is your GPS is the US based one, Galileo is a Russian based one, GLONASS is your European based, and different things. So, this is how we normally look at it. And we also have the last one, namely your low Earth orbit, or LEO. So, as I was just telling you, it could orbit from say 80 kilometers to 2000 kilometers. Initially, it was at an altitude of 600 to 800 kilometers, but as the days have started passing, and as I was telling you, you also can imagine the farther I go, the lesser the detail I get and the greater the area. The closer I am to the earth's surface, I get lesser area but better detail. So, it all depends on what kind of application I am looking at it. So, depending upon the application, they started using or designing the satellites could be from 80 kilometers or it could be up to 2000 kilometers. It all depends on the application and also the country and type of satellite. So, and again these are also used namely for say your military intelligence purposes or weather satellites, and also for natural resources. So, this is what are the most important applications. If you just look at the image, the slide, you will find how the satellites are going around. So, each of them are going around in different orbits. So, the geosynchronous satellites, the medium earth orbit and the low earth orbit satellites. So, this is about the simple detail about how the different types of satellites goes around the earth's surface. Well, we have just gone through the types of satellites, namely the polar orbiting and the geostationary satellites. Let us go through now about the elements of remote sensing, what exactly or how exactly you will be in a position to get the details about the earth's surface without being in contact with that, as I just told you in the beginning. Let us see what is the source of energy. So, the source of energy or the electromagnetic radiation, we call it as a signal or source of radiation, is a must for any kind of remote sensing, isn't it? So, we say that that could be from say a source which is available free of cost, in the sense it is readily available and it is being emitted by the sun, or it could be a kind of energy which is reflected by the surface, the land or sea, or it also could be atmosphere, through the atmosphere it can be there, and it also could be from space, or it could be generated artificially, in the sense the electromagnetic radiation can be generated artificially, and that is what we call it as active remote sensing. So, in the first case we are talking about passive remote sensing. That means you will not be generating any energy, but you will be utilizing the energy which is already available to you. Whereas, in the second case we talk about the active remote sensing, wherein which we try to generate the energy and then utilize and try to find out what will happen to the energy when it is falling on the earth's surface. So, the first and the foremost we talk about the electromagnetic radiation, other in simple words EMR, or electromagnetic radiation. And what is that important, or what you should know is that this electromagnetic radiation will be propagating through the atmosphere from the sun, propagating through the atmosphere in the wavelength like format, in the sense it will be reaching the surface in different wavelengths. What we intend to do is that we will try to find out those are that part of the energy which is possible or capable of passing through the atmosphere and reaching the surface, and we will not be interested in that part of the energy which is getting absorbed in the atmosphere itself. So, as all of you know, most of the energy are absorbed, a part of the energy passes through the atmosphere and reaches the surface, and that part of the energy which reaches the surface is called as the atmospheric windows, because it forms a kind of a windows through which this particular energy is reaching the surface. Most of the energy, as I told you, is absorbed, the X-rays, the gamma rays, all these things, and most importantly ozone layer is also preventing your other very heat related energy. Whereas, that part of the energy which is reaching the surface, namely the main and the most important thing is your visible spectrum, infrared that is again 3 parts are there, namely your near infrared, middle infrared and thermal infrared. Whereas the visible spectrum is again split into 3 different, namely the blue, green and the red. And of course, last but not the least is your microwave energy. And of course, we also have other energy. We will be seeing the spectrum a little later. Just to give you an idea, we also have other energy, namely the radio waves and the television wave. That's all at a slightly at a higher wavelengths. So the lower wavelengths, most of them are absorbed. The moderate wavelengths reaches the surface. The higher wavelengths are invariably, as I just told you, active in nature. It's all generated one. That though it reaches that will not be in it will not be in a position to use the energy, that is that I was telling you about the energy, that is especially your television and the radio waves. Whereas we talk about remote sensing being effectively using only the visible spectrum and the infrared spectrum and also the microwave spectrum. These are the 3 types of energy which is readily available to mankind, and we will be using that effectively. Yes, you just look at the electromagnetic waves, which is your atmospheric windows. So that part of the energy which passes through that, namely your, I was telling you, these are the cosmic rays, the X-rays and the gamma rays are all absorbed here, and we have the ultraviolet, I was just telling you the UV rays, the energy which is generating huge heat, and that is being absorbed by the ozone layer. And all of you know that this particular ozone layer, because of the various activities on the earth's surface, is being punctured, and these ultraviolet waves are also passing through the atmosphere and reaching the surface. Hence, there is a variation both in terms of your temperature and the weather changes, and that is resulting in say high temperatures or low temperatures. So that is not, it does not mean that always ultraviolet rays will be affecting the temperatures in the higher end, it is also in the lower end. That is the reason you have unexpected rains, unexpected storms and things like that. We also have high temperatures at a normal time. Even if you take any city for that matter, even in the case of Chennai, which was relatively better during the months of October, November, and you find it is relatively hot, and we do not know what is going to happen over a period of time. So let us not bother about that particular aspect. So let us see the energies which are useful to us. So we talk about the energy, namely the visible spectrum, and then I told you about the infrared, namely near infrared, middle infrared and the thermal infrared. Of course, we also have the microwave, which is very low in energy. Definitely will not be in a position to handle the television and the radio. They are invariably, as I told you, they are active in nature. Microwave also sometimes it is active, and we also try to use microwave to some extent energy which is also available from sun's energy. So let us see that. How does it happen? How the energy will be falling on the earth's surface, and how we are able to capture that. As you see here, this is the sun, and you find that this is the radiation which is falling on the earth's surface. So once it falls on the earth's surface, it normally gets either absorbed, it gets reflected, or it is emitted, in the sense energy which is absorbed is re-radiated. So we have the reflected energy, absorbed energy and also your re-radiated energy. However, instantaneously that part of the energy which is readily available to us is your reflected energy. Of course, if I have a little problem, in the sense if I have something like a cloud coverage or in the space, that also might affect my energy levels reaching the surface. It will get reflected from then and there, it will not reach the surface, and that part of the energy which gets absorbed and it is re-radiated. So as all know, very important is that the reflected energy. Now let us see which will be the ideal time for remote sensing. I just telling you in a day, because we are dependent on sun's energy. In a day, what do you think will be the ideal time? So just while I was telling you, can just think to what will be the ideal time. So let us say 6 o'clock in the morning and 12 o'clock in the afternoon or mid noon. So we say that if it is 6 o'clock or 12 o'clock, the sun will be invariably perpendicular in the horizontal direction or in the vertical direction. So it will not be possible or for us to use that part of the energy, isn't it? So 6 o'clock in the morning or 12 o'clock, it is not possible. Hence, we require a time or a period which will be ideal for remote sensing, namely 9:30 to say around 11 o'clock will be the ideal time for remote sensing, because we require a reflected energy and the angle should be there. Otherwise, it will not be possible for us to get that particular energy back. Hence, we depend on the sun's energy and especially the reflected energy in remote sensing, and that part of the energy which is reflected by the various objects on the earth's surface is being absorbed. And as I told you, the energy will be propagating in different wavelengths, and we will be picking up only that part of the energy which is required for our studies. Now, let us see in detail, in general rather, what kind of energy, as I was just telling you, this is your incident energy, that is the energy which is being released by the sun and it reaches the surface. It is independent of anything which is beneath whether whatever you have a water body or you have a land or whatever object beneath, it is not worried. This energy is getting reflected here, and I told you a part of the energy is absorbed here and a part of the energy is transmitted. So, the transmitted energy is not available to us, whereas the absorbed energy is re-radiated and it is released after some time. But instantaneous, at a given time, you have energy which is available to us is your reflected energy. So, it is the most important concept in say your remote sensing. Now, when I talk about this particular water body, we have the energy which is being reflected, I told you, and that part of the energy, when it is getting reflected, the energy is in different wavelengths. So, what will be the effect or what will be the impact of a particular wavelength on a particular body? So, let us say for example, water body. I was telling you of the three different types of spectrums which are important, namely a visible spectrum, namely blue, green and red. So, what will be the effect of blue energy? So, please do not get confused with blue, green, red, it does not stand for your color, it is the spectrum of your, so that is what I was telling you, the wavelength, it is a wavelength value. So, it ranges from 0.4 to 0.5 and the green is 0.5 to 0.6 and the red is 0.7 to 0.6 to 0.7 and the infrared ranges from 0.7 to 1.1. So, what is that I am trying to say is that what will be the effect of this particular energy on the water body, which part of the electromagnetic radiation is absorbed, which part is reflected. So, that is what is important. So, when you talk about water body, as all of you know, it is relatively clear in nature, but during a day when there is not much of clouds, the water will appear blue in nature. All of you know that particular thing. So, this blue color in nature will obviously be reflecting the blue energy. So, as you just go away from the visible spectrum, that part of the energy which is reaching the earth's surface, if it is a water body, if it is reflecting only blue, the other energy is mostly absorbed. In fact, over a period of wavelength variation, you will find that the energy is not at all being reflected, most of the energy is absorbed. Of course, there is another context, we say the deeper the water body, the greater will be the absorption, the shallower the water body, the greater will be the reflection. Hence, we should remember that the energy is independent and the objects are really either absorbing or reflecting depending upon the energy which it is being received. So, let us see the other aspect. Is what you call as the spectral signature, or you call it as the energy which is being reflected to on various objects. Let us see three different types, namely water body, clear, let us presume it is a clear water body, vegetation which is invariably green in color, dry barren soil which is grey to brown color. Now, what will happen to the energy? As I was telling you, the wavelength versus the reflectance. When you talk about the water body, you see here within 0.54 to 0.4 it is relatively less, 0.5, 0.6 around that range it is reflecting a little more. When it comes to 0.7 and 0.8, that is when it is nearing infrared, the energy is absorbed maximum. Whereas vegetation, as all of you know, blue color it will absorb. Obviously, the color of the object is green and you find 0.5 to 0.6 it is getting reflected. Once it is coming to red color, 0.6 to 0.7 it is getting absorbed, and once it reaches the infrared you find a huge reflectance. So, the entire spectrum of infrared you find that the energy is reflected by the vegetation thoroughly, and again it falls down, and as it goes beyond that it will be reflecting and absorbing depending upon the energy. So, we find that the water body and the vegetation behaves differently with respect to different types of wavelengths. And if you see here dry barren soil, you can see here there is a steady increase in the reflectance of the dry barren soil over a period of distance from the say your blue to infrared. But when you come here, it again just increases, it just falls down little in infrared, that is your thermal infrared, and it just again increases and falls down, and it varies here in different shades. So, you find that dry barren soil will be in way in which this is the way in which it will be behaving, whereas The same soil, if it is moisturized, if it is wet in nature, naturally there will be a lot of absorption. It will be behaving with respect to how it behaves with respect to water. So, the greater the water content in the soil, you will find the greater the absorption. So, let us not go into too many details about that, just get an idea. Different objects behave differently with respect to different wavelengths. So, that is the bottom line I want to explain you.